4.6, number 262. I want to use this example to talk about the indeterminate form infinity over infinity. It doesn't really matter what type of infinity it is, right? So sometimes it's written like this to show you that you have a bunch of options here. It doesn't really matter what type of infinity you have above or what type of infinity you have at the bottom, i.e. it doesn't matter what infinity the function is approaching in the numerator or what infinity the function is approaching in the denominator. Either way, it's an indeterminate form. We do not really know what's happening. All right? So forget the plus or minus for 1 second. We just look back at this. If the function is growing very large in the numerator, that makes the overall ratio very large. If the denominator is growing very large, that makes the overall ratio very small. So again, we don't know how these two are going to interact with each other. Will, in a sense, the numerator win out and this ratio will just become infinitely large? Will the denominator win out and the ratio head towards 0 as the denominator gets very big? Or is something in between 0 and infinity again, because somehow they complement each other just right. Their rates heading towards infinity are just comparable enough that you'll get some finite value coming out of this this limit here. So in the example here, in problem number 262, you have the limit as x approaches infinity of 2x minus 5 over 4x. All right, clearly, as x gets very large, well, 2 times very large is very large, and minus 5 is still pretty large. The minus 5 doesn't really do a whole lot to the 2x, which is, racing towards infinity. 4x on the bottom is also racing towards infinity. You might say a little bit faster than the top because it's multiplied by 4. But again, there's not much of a difference because as the numbers for x become more and more gargantuan, the difference between 2 times gargantuan and 4 times gargantuan becomes less and less significant, you might say. Anyway, but we do see that it's an infinity over infinity case. They happen to be positive infinities, but again, it doesn't really matter so much what types they are. But they are heading towards positive infinity, both above and below. So again, what that means for me and for you is there's hope to find a finite limit. Perhaps there's a finite limit to this as an answer. Perhaps there is finite limit. And in these cookbook, textbook problems, there probably is. Can't guarantee it every time, but most likely. So let's see the algebraic approach you're supposed to take here. You are supposed to divide off numerator and denominator by the highest power of x. So the highest power of x I see around here is x to the first. So we will take 2 on x minus 5 on x. So there's the numerator divided by x. And you'll just stand at the bottom. This is algebraically legitimate because, well, for one, x is not 0 because it's racing towards infinity. I don't have to worry about dividing by 0. It's nowhere near 0, you might say. And I did the same thing to the bottom that I did to the top. So this is algebraically equivalent to this. All right, what happens? Well, these x's cancel, these x's cancel, and we have our limit written in a new way, perhaps a more insightful way. It has 2 minus 5 on x over 4. Okay, so now as x heads towards infinity, there's only one variable here, and it's below the 5. And as the denominator for 5 on x gets very, very large, right, this is heading towards infinity, as it says right there. So the overall 5 on x value, since 5 is fixed at 5, right, constant, and this is growing without bound, it's safe to say that this ratio is heading towards 0, right? It's becoming very insignificant. So therefore, we should have 2 minus 0 on 4, which is of course 1/2. There is our answer to this limit.